Hello everybody. Today's video we're going to talk about what does Blueback ODiSI really tells me, how to use the post-inversion QC tools. So first of all, thank you for signing up. This is the last video of series 2, so if you want to see more, tell us what you want to see. If you want to find out more about any tools, please contact your Seagal account manager or email at sales@seagal.com. So the format, each session will last between 20 and 30 minutes. Each session will be recorded and you will get a copy of the recording via email 24 hours after the webinar ends. The recording will also be loaded on the Seagal YouTube channel. If there is time for Q&A, please submit your question via the chat tab in the GoToWebinar console. So summary for today. So the situation is we have an ODiSI inversion that was performed and which has gave us different type of output. Our challenges is how to make the most of the outputs. Our solution will be to use the post-inversion tool in ODiSI. This tool allows us to create some maps and cases, which are called approximate percentile, 10, 50, and 90. And with these cases, we can create maps and volumes. And we will also analyze our output using Blueback Investigator. But before going into Petrel, I want to introduce you a little bit on ODiSI. So ODiSI, it stands for one-dimensional stochastic inversion. It's a facies-based inversion that gently estimates facies, reservoir properties, and their associated uncertainties. ODiSI inversion runs by matching a very large number of pseudo-well realizations simultaneously to multiple EEI chi projection volume. The algorithm is simple, robust, and published. So our problem can be defined as a solution space, which is our prior probability in Bayes wording. ODiSI will then sample the prior, compare the sample to our data, which is our seismic, and accept or reject the samples based on a quality threshold. For ODiSI, this threshold is an RMSE value. The selected sample in yellow here is our posterior probability, and you can see it's narrower than the prior. So we have better output. To sample the prior in a meaningful way, we can use prior knowledge, which can be well log, depth trend, vertical statistics, geological model, and so on. So we take information from this prior knowledge, we compare with our data, our seismic, and we have our posterior, which is our characterization. Sample or pseudo-well realization are stratigraphic profiles created using a time Markov chain using two matrices. First, a bed thickness, which is created using maximum, minimum thickness and proportion, and the transition, which is a transition from one facies to another. And this is constrained by the prior. For each vertical stratigraphic profile, the full suite of log is created using rock physics model. ODiSI uses three types of rock physics model, one for reservoir, non-reservoir, and laminated. Again, this is constrained by the prior. So how ODiSI works? In this example, we have one input volume, which is the EI chi volume. For each seismic trace in these volumes, ODiSI creates thousands of pseudo-well with a full suite of log, including the EI chi synthetics. Those synthetics are then compared to the real seismic data, and based on the matching threshold, either accepted or rejected. The best 100 best match pseudo-well, which have the lowest RMSE values, are then selected. Each of these synthetics have a corresponding lithology column and all the fruit of log. So we can then average the different properties, which give us different information, so probabilities, like here, lithofacies probabilities or net to gross. So ODiSI, or low frequency in ODiSI. ODiSI doesn't use a low frequency model because a deterministic low frequency model can bias the result. Here on the right-hand side, we have three examples of low frequency model created using different net to gross. We can see a very large variation in the subseismic frequencies. And these are only based on the different low frequency net to gross. So it means that applying one of these models, we create a bias in our result. ODiSI geological parameterization, which allows the creation of pseudo-well with different net to gross, constrain the low frequencies. This recognizes the uncertainty of the low frequency information. So matching, the process is 1D, one trace at a time. For each trace, thousands of pseudo-well are created with EI-based synthetics. Synthetics are consistent with the seismic wavelet and AVO, so thanks to the chi-angle. All pseudo-well are then compared with the seismic trace, and the best 100 are selected. For the property estimation, each of the pseudo-well has a complete suite of curves. We select the property of interest and average the curves corresponding to the best match synthetics. So here, for example, our V-shell curve. This provides both the mean and variance of the estimate for each sample, which is our posterior. So once we have our main ODiSI result using the 100 best match, we can also do some post-inversion QC. ODiSI has a post-inversion tool which allow to make the best of the ODiSI outputs. So first we can create maps, net to gross map, porosity map, and so on. And we can also create cases, which is a creation of different approximate percentile cases. And I'm going to show you what I mean by approximate percentile. So when we have our main ODiSI output, we have 100 best match pseudo-well, which are 100 statistically valid match to the real seismic trace. By default, the 100 best matches are ordered by RMSE value, but we can order by different property, for example, net to gross. To understand the variability within the 100 best match, the approximate percentile averages only a subset of the 100 best match pseudo-well. So, for example, here we have our 100 best match order by net to gross, sorry. So if we want to have, if we can also, well, sorry, we can average only the 20% around the 10th trace, sorry, and this will give us the approximate percentile 10. If we do the same process around the 50th trace, we'll have the AP50. And if we do it around the 90th, we have the AP90. So that's all for the PowerPoint. Let's jump into Petrel. So for today's video, this is our output from the our ODiSI project, and these are all the values that the output that we can have. So ODiSI, like almost all our tool, is located in Marina. When you open the tool, so ODiSI is composed of different tools. Create ODiSI, where you're going to create the rock physics model using your well data and your prior information. Statistic QC is where we're going to create the matrices for the creation of the stratigraphic profile. Inversion QC is where we're going to use all the information that we have created before and bring the seismic information. Inversion realization is where you're going to select all the different outputs that you want to create, and post-inversion QC. So for today's project, so here we have our main ODiSI output. So for today, I'm going to focus only on the probable lithofacies, which is this output, and the probability of each facies. So what I've done, I want to focus today's video on our main body. So what I did earlier is I've just used a geobody extraction to extract this main body. I've also just created two surfaces, top and base of this geobody, to focus our analysis on this interval. So once you have our output, we can go into post-inversion QC. So this first step is to select the metadata that is created with the inversion. Then we select the cases. So here we can either use all, which means all of the 100 best match pseudo-well, or approximate into gross percentile. For the moment, I'm only going to use the 100 best match. I don't want to create the cases just yet. Then you go to output, and here you can either create maps. So here I can select, you can add and create different maps at the same time. I'm just going to add my surfaces, and this will create the average of net to gross, porosity, and so on between my these two surfaces. I can also create net to gross histogram map. I'm going to show you later what it means, and also the probability of finding clean sand with a bed thicker than 10 milliseconds. Then you just have to click create and the tool will run the output. And this is the type of output that you can obtain. So here on the left-hand side, I have a map, which is a net to gross mean between the two surfaces. So for my main geobody. And on the right-hand side, you have the probability of clean sand bed with a thickness greater than 10 milliseconds. So you can see right away where you have a thick clean sand. The second map that we have created, or type of map, is the net to gross histogram map. So for these maps, the tool will calculate the distribution of net to gross values within the 100 best match pseudo-L. So this gives us an histogram from 0 to 100. So each sample in this map, or for each maps, represents the number of pseudo-L with a net to gross value in the selected bin. So here, for example, this is the bin 10 to 20. So one sample corresponds to the number of pseudo-L which has a net to gross between 10 and 20. So this is the first step to understand the distribution of net to gross within the 100 best match pseudo-L. So is it centered toward a low case, mid case, or high net to gross values? In this case, the maximum number or the highest number of pseudo-L is in the bin 30 to 40. So here is what we can do with our main ODiSI output. We have started to understand that we have a variation within our 100 best match. So the next step is to create cases. So I can go back to my post Inversion QC. My output, I use the same metadata. And for the cases here, instead of using use all, I will use approximate net to gross percentile. So I can select the percentile that I want to work with. I usually work with the 10s, 15, and 90s, but you can change the percentile if you wish to. I want to order my 100 best match by net to gross, but you can also change these values. Then for the output, you can create the maps that we have already created for the 100 best match. And here you can also create volumes. So these volumes will be the average of 20% of our 100 best match centered around the 10th, 50th, and 90th trace. Once you do that, you have, so I talked first about the volumes. So here on the top left-hand side, you have the probable lithofacies with using the 100 best match pseudo-L. On the right-hand side, at the top right-hand side, you have the AP10, which is our low case scenario. And you can see that our clean sand bed is thinner compared to the main ODiSI output. Then we have the AP50 and the AP90, where you have the thickest sand. Because we have different outputs, we have seen the lithofacies, we can also have the net mean. So for ODiSI, net mean is 1 minus V shell. So again, on the top left-hand side, you have the net mean using the 100 best match. On the right-hand side, the AP10, you can see also the difference again. AP50 at the bottom left-hand side, and the AP90 where we have the highest net to gross values. So we have our volume, but we can also have our maps. So for example, net to gross maps. Again, on the top left-hand side, the main ODiSI output using 100 best match, and the AP10, AP50, and AP90, where you can see the difference in net to gross. So all the maps have the same color code, so to allow for an easy comparison. So this is net to gross, but we also have the probability of sand thickness, sand bed thickness. Again, probability of clean sand greater than 10 milliseconds, and you can see the large variation within our 100 best match. So it exists a lot of different ways to use the data. The volume can be upscaled to a grid. The maps can be used as a guide for the modeling process. So if you want more information about how you can use these maps and volumes, one of our consultants made a white paper on this subject. So please do not hesitate to ask for it if you're interested. For today's video, I'm going to analyze this information a little bit further using Blueback Investigator. So I've created earlier several investigations using a different type of data. So for this first example, I'm going to use surfaces in my investigation. So Investigator, it's a powerful cross-domain data analyzer. So here for this example, I've used the surfaces with net to gross data for the 100 best match pseudo-well, the AP10, AP50, and AP90. So this is the value, the data that I have here on an histogram. It's colored by my cases, and I have the value, the net to gross value between 0 and 1, and the statistics. So you can see right away that the 100 best match for ODiSI is this black rectangle, and you can see the variation between my cases. So in this cross plot here, I'm using the all surfaces. But what I can do is use a spatial selection to refine a little bit further my analysis. So here on the 2D window, I have a spatial selection displayed. What I can do is select my Blueback histogram window and select this spatial selection. And this will update my data. So here, my spatial selection is in blue, which is not very nice. So I just change it to red, and this is the data. I'm just going to deselect this. I will deselect the point because I'm not interested in the point outside my spatial selection. What I can do now is select my spatial selection. I'm not using the correct one, sorry. So this is the data that I want to remove in purple. So you can see that I have less points. So what I want to do now is be able to analyze different area in my surfaces. So what I can do is I can select my spatial selection and narrow it down a little bit. And you can see right away that the histogram is updated on the fly. So here I can have an analysis around my well A, and try to understand the differences between my 100 best match and my cases. If I want to understand or analyze only the difference between my cases, I can deselect the main ODiSI output, and I can also change my area to understand the variation also in the spatial world. So this is using surfaces. What I also want to do is analyze a little bit further the probability of each facies. So again, sorry, I've created an investigation, just updating, sorry. And for this investigation, I've used a probability of each facies. So just take a minute. That's the inconvenience of live demo. So here for this investigation that I'm going to open just for you to have a look, I've used the main ODiSI result, so again, which is a 100 best match pseudo-well, and the probability of all my facies for my AP10, AP50, and AP90. So here, again, this is my output, my volume, and I've created here a spatial selection where I have narrowed down my volume using a top and a base, which are the top and a base of my main geobody. So on the right-hand side, I have the histogram for all my facies. And again, you can compare the 100 best match and all the cases. Again, you can deselect some cases if you want. Here, this is for the full volume. It's a little bit too much for to analyze really. So what I want to do is to use my spatial selection here, this yellow. So I select my histogram window and select my selection. So again, I want to just remove the data that are outside my filter. And now I can really understand the variation for each of the probability of my facies, the difference between the cases, and also the 100 best match pseudo-well. If I want to go and compare this data with my existing grid, for example, I can do that. I have created a third investigation which compare the probability of each facies, so what I've just shown you, and the probability that I've created in my grid. So here, because investigator allows you to compare different type of data sets. So here I have my 4 type of data sets which are seismic, coming from ODiSI, 100 best match, and my cases. And I have also my 3D grid data with the probability of each facies. So here again, I can use my spatial selection to have to refine my analysis on only the main body. And here you can compare a little bit further again the data using the spatial selection. So here at the moment are displayed only the 100 best match pseudo-well and the 3D grid. So you can try to analyze and understand why you might have a difference in the probability of each facies. If you want to compare the AP10 with the 3D grid, you can also do it. And as you can see, you can also display the cumulative distribution function that you can export if you wish as histogram to petrel function if you want to use it in another tool. So this is the end of the demo. As a summary, ODiSI post-inversion tool allows us to create easily some maps, so using different property using the 100 best match pseudo-well. Also on different property using only a subset of the 100 best match pseudo-well, what we call cases, so approximate percentile 10, 50, and 90, for example, allowing an analysis of the variation within the best solutions. We also created probability of sunbed thickness greater than 10 milliseconds. The 10 milliseconds is a parameter that you can change. And we also created net to gross histogram maps, which is your first step to understand the variation within your 100 best match pseudo-well. We've also created volumes, different property using a subset of the 100 best match pseudo-well. Also, Blueback Investigator allowed us to bring our analysis a little bit further. So we use spatial reconnaissance using Blueback Spatial Selector. And we have to realize that Investigator is a powerful cross-domain analysis, enabling easy comparison of seismic and geogrid data. As a conclusion on ODiSI, so ODiSI is a 1D facies-based inversion which produces geologically meaningful results. It's a rigorous method based on sampling the prior that captures the uncertainties of the process. Uncertainties can then be analyzed in different ways: cases, net to gross histogram maps, probability of bed thickness, and so on. The algorithm is robust, simple, transparent, and published in a peer-reviewed publication. We have high-quality results validated on multiple fields and even on some carbonate reservoirs. So this is the end of the video. Thank you for watching today. And we would really like to thank you for your continuous support for both video series. If you want another series, please let us know. If you have any question, do not hesitate to send an email to support.geo@sigal.com. And I think we have 5 minutes if you have any question. Thank you. So we don't have any question, but please, if you have any question today or later, please do not hesitate to ask an email to send an email to either webinar@sigal.com or support.geo@sigal.com. Thank you very much.